In this particular section, we will learn to differentiate the important kinematic concepts of position, time, and the displacement for motion in one dimension. You will be able to recognize the algebraic significance of you will be able to recognize the physical significance of the algebraic sign for position and the displacement vector. And lastly, you should be able to distinguish between the distance traveled by an object in one dimension and its displacement. So let us analyze the motion of a man jogging. So the question is, how do we describe the position of this jogging person? In order for us to measure his position, the first thing we need to do is to establish a reference axis. A reference axis simply is an imaginary line that runs along the ground and really has an origin. In this case, this is our origin, which essentially is our chosen reference point. Now, to specify direction, we will introduce unit vectors. A unit vector is any vector of magnitude 1. It has no units associated to it. Now, the importance of unit vectors in physics is that they are used to define the direction of a vector quantity in space. In other words, the purpose of unit vector is to specify the direction of a vector quantity in space. So in this particular case, I'm going to introduce a unit vector in the x direction. This is I hat. So any vector quantity that is accompanied by this unit vector is directed along the x direction. That is what it means. Now keep in mind that an arrow that points from the origin to where the person is jogging defines what we call his position vector. So the question is, how do we define his position? The very first thing is we know the reference point, which is the origin. So we need to measure this right here. Let's call this his initial position. A vector or an arrow drawn from the origin to where the guy is jogging defines what we call his position vector. So if I draw an arrow from where he is, from the origin to where he is jogging, this will define his position vector. This is Ri. So in this particular case, his initial position vector Ri bar is going to be equal to xi I hat. Keep in mind that I hat is the unit vector along the x direction. So in this case, we have defined his initial position. So the question would be, what would happen if he jogs to the right? So if he jogs to the right, let's say to a final position, this is his final position xf. So we have here his final position. His final position vector will be an arrow drawn from the origin to where he is currently jogging at the moment. But the most interesting part is that his displacement is defined by this distance. We will call this displacement the change in his position. So his displacement delta x is simply defined as a change in his position. Remember that the sign delta simply means change of. So if you see the sign before anything, like for example, that sign means change of t. Hence, we can therefore define the displacement delta x as his final position minus his initial position vector. Recall that his initial position vector is just going to be x I hat. His final position vector is just xf I hat. This would mean that his displacement vector is going to be xf minus xi multiplied by I hat. This is his displacement along the x direction. Now, the next thing that you need to bear in mind is that the displacement of an object is measured in meters. The displacement of an object is measured in meters, and it is a vector quantity because it has a direction associated to it. The most important thing that you need to take note about displacement is when you observe this definition, you realize that the displacement of an object depends only on the final point and the initial point. Depends only on the final point and the initial point. That means that the path he takes from the initial to the final point really doesn't matter. So the displacement of an object is a state quantity because it depends only on the initial and the final point. Now this brings us to one definition. What then is the difference between the displacement of an object and the distance traveled? That is a very good question. The distance traveled is the total length of path covered by an object as he or she moves, while the displacement of an object really is just the difference between his final position and his initial position. Take note of the difference. So the total distance traveled here is d. So distance is a scalar quantity, while displacement is a vector quantity. So if you have any questions regarding what we are talking about, please do not hesitate to ask in the discussion forum. So the question is, how do we distinguish between distance traveled and displacement? How do we distinguish between the distance traveled and the displacement of an object? The best way for us to do so is to consider this example. Now, a man runs from A to B, then from B to C, then from C to D, and then from D to E. The question really is, what is his total distance traveled and what is his total displacement covered? Remember that displacement is the change in the position of the man. In other words, his displacement is the final position minus the initial position. So the displacement delta x will just be the displacement at E minus the displacement at A, because E is his final destination and A is his initial destination. In this case, his displacement at E is 4i, minus his displacement at A is 1i, so this gives us 3i meters. In other words, he is displaced 3 meters from the origin. This defines his displacement. But what is his total distance traveled? His total distance traveled is the magnitude of his displacement. So it is the magnitude of his displacement. What does that mean? This is equal to the distance traveled from xb minus xa plus xc minus xb plus xd minus xc plus x of e minus x of d. So this will be equal to the magnitude. This is 18 minus 1 plus x of c. This is 10 minus 18 plus x of d, 14 minus 10 plus x of e, 4 minus 14. So this will give us 17 plus 8 plus 4 plus 10. Keep in mind that the magnitude of negative x is just gonna be x. If x is positive and the magnitude of negative x is negative x, if x is originally negative. So if we do the total calculations here, this is going to be 8 plus 4 is 12, 12 plus 10 is 24, 24 plus 10 is 34, 34 plus 7, that's going to give us 41. So this is 41 meters. So you see that in this example, he traveled a total distance of 41 meters, but his total displacement was just 3 meters. Just 3 meters. So there is a remarkable difference between the displacement of an object and the distance traveled.